Hi, it's Jan Beta, and look what just arrived in the lab from long-time supporter Alistair, aka The Geek, who also runs a brilliant blog about retro repairs and some more modern stuff. Definitely recommend checking out his work. I'm going to link things in the video description. Thank you very much for this. This is a ZX Spectrum Plus. I don't know a lot about these Spectrums. I think they are basically the same construction like the rubber key versions, like the original 16K and the 48K ZX Spectrums without the Plus, but they have, instead of the rubber keys, they have these chiclet keys, which also have like a membrane, very similar to the rubber keys underneath, but they already feel a bit nicer to type on. This particular one is slightly broken, if I remember correctly, and has like a scrambled video output problem. And yeah, I'm going to make this a series of shorter videos, I think, because this obviously needs some refurb work, like some cleaning. The enter key is a bit stuck. Yeah, or quite a lot actually, not only a bit. So this actually needs some work on the case, and some of the colors here are rubbed off a bit, and it needs a thorough cleaning. Today I'm going to try to fix the fault at first. So obviously the very first thing I want to do is to take a look inside. For that purpose, I turn it around, and it has... Okay, usually these have more screws. This has only 4 the buttons. I like the fact that this has like little standoff thingies to raise it up to make typing even more nice, or slightly nicer than without that feature. But they put some thought into this, and as with all the Spectrums, I absolutely love the design. It looks absolutely tremendous in my opinion. The rubber key, I like the rubber key one a bit more even design-wise, but this looks amazing. Like the keys have their unique design, and the little rainbow and the striped case, very excellent design. So if you see a picture of this, you think that's a very nice computer. If you see it in person, you still think it's a very nice computer. And then you start typing and think after a while, probably, whoa, okay, this isn't as nice as I'd hoped for. Okay, 4 screws on this one. Usually it's like 6, 7, 8 screws. So in theory, hey. And indeed, this is the same board like with the rubber keys, and you want to be really extra super careful with the membrane connections here. Yeah, these are already gone. Fortunately, Alistair provided a replacement membrane for this right away, because basically on all the rubber key and the Plus Spectrums that have the same kind of membrane, the membrane, at least the connections to the board, fail because they just get brittle with time and with heat and things like that. And yeah, these are really, they go quickly. Actually quite a nice design here, these standoff things. Okay, not too bad. Yeah, so the board is, I think, in issue 4A. The silk screen is a bit rubbed off there, and yeah, it looks good actually. Still has the original, it's all original, there hasn't been anything done to this, I think. There are some of the mods that are like factory mods. They had all kinds of weird stuff going on to make up for like timing issues and things like that. And that's why you see a lot of weird looking mods on, I think, on all the revisions of the Spectrum boards. Okay, but this looks to be in original condition. And also one feature that's particular to the Plus version is this reset switch on the side here, which is pretty nice actually. I think I can take out the board without even desoldering this. Yeah, actually pretty nice. Okay, let's try that. Let's try to remove the screws here. And this one. No, that's it. Okay. Yeah, I think I want to remove it. Okay, I want to desolder this so I can properly work on this, I guess. So there we are. ZX Spectrum 1983 issue 4A. And because these crinkled boards always get some comments in the comments section, I'm just going to say that again. This is normal actually. They came from the factory like this. They just added an extra layer of solder actually. Before they added the solder mask to have the traces like this ground plane gets more current carrying capabilities, so it gets a bit wider through just adding an extra layer of solder. And yeah, just if you add a large area of solder, it just like cures like this, so you get the wrinkly effect. Absolutely normal. Many C64 boards have the same. Okay, so let me actually desolder the reset switch here. Okay, that's better. Wow, okay, there's a bit of foam that is really like just dried up and very... Let me just remove that really quickly. That's just dry. Wow. Okay. It's just completely dried up. Interesting. So first thing I want to do is actually do a composite mod on this. These old ZX Spectrums only have an RF out coming from this RF modulator, but they actually have a composite signal coming into the modulator through this little wire here. And you can just basically mod them by cutting this and adding a wire that goes directly to this RCA socket, which normally provides the antenna signal, the RF signal, for connecting to an old analog TV, which I don't have handy in the lab here at least. Yeah, you also cut this 5 volt. I made a whole video about this mod. It's the same on the rubber key Spectrums. So, okay, popping open the hood of the little RF modulator can. If I can, it's a bit rusted. Wow, okay. So, as I said, we basically just cut this, which is the 5 volt supply, to the little RF modulator. So now we can bend it to the side. The RF modulator is without power. Then we cut this, which is the video signal, to the RF modulator and bend it to the side. And we run a wire from this point on the circuit board to the middle pin on the RCA jack. And we cut this resistor that's soldered to it originally, bend that out of the way, and connect the wire to this. The ground connection is already made by the outer shell of the RF modulator, so you don't need to worry about that. So yeah, now we feed this little wire that I just soldered onto the video point there. We feed that in through this hole here. Actually, it doesn't really fit very well, but I'm going to pull it through. So there's not that much room in here. Actually, I'm going to make this a bit shorter still. So with this mod we should now have a composite out on our little RCA jack. Should be able to see what this thing actually does. As a power supply, I'm using my MeanWell GS18E09, 9 volts, 2 amps, center negative. This is actually a modded power supply. I just reversed the polarity of the plug because the Spectrums, as well as the Commodore 16s, take a center negative signal, which is highly important if you don't want to wreck your machines instantly, basically. Okay, first of all, we had a really dirty RCA jack there. I need to spray some contact cleaner in it. And now that is the picture we get. There is an output, but it's blinking and distorted and scrambled. So we're going to have to do some troubleshooting. Yay! So first of all, let me clean the RCA jack here. Just spraying some contact cleaner in here and plugging and unplugging my plug here for a couple of times. So also that should get rid of those problems there. Okay, let's first of all take a look at the supply voltage provided by this little 7805 voltage regulator. Oh, it also clicks. The little speaker clicks frequently. Okay. So we should have 5 volts on the rightmost pin here. Oh, it's 4.92. That's a bit low. That is actually a bit low. So I suppose there might be something shorted. Or something like pulling too much current. Maybe it's even just the voltage regulator. Yeah, so there is something wrong there with the voltage supply. You can see that right away. We have like 4.9 volts on the chips, which is too low. I kind of suspect the 4116 RAM chips to have some defects. They are particularly prone to failure and usually result in like a scrambled screen output and the computer not starting up properly. We have the voltage supply is -5, ground is on the top right pin, 5 volts bottom right, 12 volts bottom left pin. So we have like 3 voltages that these need that have to be present to work. Let's see if our voltage supply works. This should have +5. It's like 7 volts. Okay, that's not good. We have -5, that's okay. 12, spot on. Okay, we had like 7 volts there, that's not good. And now we have 4.9. I'm inclined to just replace the 7805 at first. Ooh, also the whole board smells like fish, so we definitely have some leaky capacitors on there, which is no wonder considering the age of the machine. Yeah, I guess we should replace the capacitors as well, every single one of them. If you smell something fishy on a piece of electronics that has capacitors, like electrolytic capacitors, like these barrels, and is elderly, let's say. This was made in 1984, according to the date codes. And yeah, chances are very high that you have leakage, like leaked electrolyte, because that smells fishy. So it might very well be. They didn't use the best capacitors for these well, so. And I think I can spy some corrosion here as well. This lag of the capacitor, there seems to be some corrosion going on there. So that might well be leaked electrolyte that is eating away the circuit board there. Yeah, at the very least, it is quite scratched there. Don't know what happened there. Okay, putting in a new 7805. I'm just going to put some thermal paste on that thing. The original one didn't have any thermal paste, so I'm just adding some for good measure, because that makes sense for heat conductivity. And I have some of this thermal paste here that is made for transistors and voltage regulators and things like that. So the right stuff for this job. Okay, basically the same picture. Slightly changing. Okay. Let's see if that provides the right voltage now. Yeah, that's better. That's 5 volts. So the voltages look way better now. This is our 12 volts. This should be our 5. Yeah, that's pretty spot on. This should be our -5. Yeah, that's way better now. And we have a different behavior slightly. We have the border, which tells me that a lot of the system is alright. We have flashing characters here. We have different colors, we have noise, noisy, scrambled stuff happening there. So I still suspect that it's kind of a RAM fault, some description. Okay, another relatively easy thing I can do is to get the ULA chip out, which is kind of like the PLA in the C64, like directing the signals and making the system work. Because this is socketed, but wow, this is in there pretty good. Oh, there we go. Ooh, okay, there's some pretty corroded pins on that. Or like in the socket at least. Let's clean that up a bit. Maybe that is already all that's to do here. Yeah, there's definitely some corrosion on there. Let's see if that changed anything. Nope. Let's see if we can reset the system by just shorting the reset pins here. Yes, that works. And then it goes back to the normal behavior. Okay. We can reset the processor. Let's maybe try another ULA. I have a spare board that we can take the ULA off. I still suspect RAM as my main suspect, but none of the RAM chips get warm or anything. So here's another Spectrum that actually works, but kind of looks messed up, but it's kind of a good test system. Okay, let's see if the ULA from that one, which is the exact same model, works with this. Nope, exact same. It's a random blinky thingy. So what I'm going to try now is a method called piggybacking, whereby I take one 4116 RAM chip and just make contact on top of the other RAM chips and see if the behavior changes for any of these if I just put that on there. The reason behind that is being that if one of these chips is shorted, the chip on top will take over basically some of the functions and change the behavior of the system. Sometimes you even get it to start up like this, but you want to look for basically change of behavior for the colors or something like that. And maybe you can have that hints at the RAM chips that are maybe broken, which I suspect in this case, because we have a border in the picture. That means I guess the processor is fine, I guess the ULA is fine. It very much seems like a lower RAM fault, this is the 16K of lower RAM, the upper RAM is here. So this is a 48K RAM machine. There are some, like, for example, my little spares ZX Spectrum here, that only has this portion of RAM populated, so that's only 16K of RAM. I took one of the 4116 known working ones, and I'm using that to piggyback this one. So let's see if that does anything. Okay, leftmost chip. Now, of course, turning this off. No, that's the same picture we got before. Next chip. Okay, that seems to be the same as well. Of course, you have to make sure that these make good contact. Oh, that's different actually. Okay. No, that's the exact same. Changes the behavior. Okay. Let's mark that chip with a little X. Okay, that's also different, it seems. That's the same. That's different. Same. Same. And different. Okay, let me double check this. Yeah, that definitely changes with that one. Yeah. Let's put a question mark there. So here's what I think. Because piggybacking this one and this one changed things visually, I think at least these two are broken. So I'm going to replace them with some chips from my spares collection. It's interesting to see that these are actually from different weeks. So they had like these have different printing on them as well, different lettering. Maybe they came from a different factory. These are from different batches. But I think RAM usually fails first. If you got a power supply issue, RAM is pretty prone to shorting out and failing basically with that. So yeah, it's kind of suspicious. I kind of suspect these two to be the culprits at least. Maybe this one, this This one showed me different behavior, and this one also was a bit suspicious. I think I want to desolder these two and put new ones in, known good ones, and see if that changes anything. Yeah, upon desoldering some of these RAM chips, I realized that a lot of these solder joints are really badly done. This is the one I desoldered, and this is one I didn't desolder that almost looks like, yeah, there's very little solder in there. So I'm probably going to end up resoldering a whole bunch of solder joints on this board as well. It seems it's the same all over the place basically. So yeah, that's another thing to consider. Wow, so there were quite a few spots where there wasn't even enough solder to make a connection, I guess. I resoldered most of what I found. The pin spacing on some of these is very narrow, so you have to be careful to not produce solder bridges where there aren't supposed to be bridges. But yeah, I think I managed to halfway decently do this, and maybe some of the connections didn't make a good connection, so maybe chances are it's better now. Okay, that's different. That's definitely different. Oh, okay. That's a bit better. Okay, let's replace more RAM chips, I guess. That was kind of promising. I did a bit more piggybacking there, and when I piggybacked this one, it nearly got back to what it's supposed to look like with a white background and black text. I'm going to replace this and this as well, just to make sure. These were the ones that sometimes made a difference. Going to do the exact same thing. I always put in sockets so I can easily replace the chips in case they go bad again, or just to try different chips in different positions and things like that. And these RAM chips are really old and they are not very reliable anymore, so it is a good idea to put in sockets to be able to replace them quickly should it become necessary. Okay, better. It's pretty close to how it's meant to be, actually. This looks a lot more promising than it was. Let's reset the machine. Oh, let's try that. Yeah, there's something humming in the speaker there. But getting there, maybe. Maybe we're getting there. Yes! Okay, I piggybacked one more RAM chip and we have a picture. Getting there. Okay, I piggybacked this leftmost RAM chip now, and look! We're nearly there, I think. I think we have to replace that one, and then we actually have our startup screen, which looks like this. Okay, let's do this. Yes. Okay, the RCA socket is still very, very wonky, but look at that. We're there. We have our screen. Reset works as well. So it was just an issue with the RAM, it seems. Let's see if we can start something on this one. So I have my diff MMC Future from the Future was 8-bit, which I can only recommend. It's a brilliant SD card solution with a joystick port on it for the ZX Spectrums, all of them. And yeah, as you can see, it works flawlessly. I think there's probably updates for this because I haven't used it in a while. Unfortunately, while this works, I can't really do anything with it because the keyboard does not work at all. So I tried connecting this, but the ribbons seem to be damaged in a way so that, yeah, we don't even get anything out of this. Fortunately, Alistair also gave me a new keyboard membrane. So we are going to be able to just replace the old broken one with the new one, which is what I'm going to do now. And of course, obviously, we have to take this apart again, probably because I want to refurbish and clean the keyboard pretty thoroughly still. But yeah, I think it's worth it for just trying this for now. Okay. There's a hair. Okay, so this is the old rotten membrane. And this one should go in here like so. Oh, there's some lametta. Is that what it's called? Glitter. Pink glitter in here. Nice. Look, pink glitter. Going to frame that probably. So yeah, we are definitely going to open this up again at some point, but for now, should line up this thing here. Should put some of the screws back in. Now for the big moment of bringing the two together. Our mainboard and the keyboard. Both boards in their own right. Wow, okay, this feels much better than the old one. Way, way better. Okay. So, should put something between there that's non-conductive, like a plastic sheet, like so. Yeah, that should do. Okay, let's see what this actually does. Okay, we don't have any keyboard response at all. That's bad. Oh, there we go. We have some keyboard response. Okay. Oh, it's mapped differently. Okay. It is mapped differently. We have the key map from the rubber key spectrum, it seems. Okay. That makes sense. Okay, let's have the diagnostics running now. Run in soak test mode. Yes. Yeah, so other than the keyboard having a weird key map, which is the one from the rubber key, and the dedicated arrow keys don't work, I bet there's a way to get them to work with the diff MMC future. Everything else works, and the machine passes all the tests. So I call this repair a success, and I'm going to be back with another video where I refurbish the machine and future-proof it probably by replacing the capacitors mostly. They seem to be in pretty bad shape. So yeah, that's what I'm going to do. Probably going to add some heat sinks to the ULA and the ZZ80 processor, which also gets really warm. And maybe even replace the remaining 4116 RAM chips, just to be sure that there are proper RAM chips in there. For now, this seems to be a success. We are running iteration 5 of the RAM soak-in test here. So this machine works, no problems whatsoever. Yeah, thanks so much for watching. Thanks for your subscriptions and your thumbs. And also special thanks to my Patreon supporters and the supporters on the YouTube membership page. So without you, these videos wouldn't be possible. So thank you very much. And yeah, that's it for today. Thanks for watching. I'm Jan Beta. Hopefully see you next time. Bye.